Assalamu alaikum. Today I want to discuss on electron emission. The liberation of electrons from the surface of a substance is known as electron emission. For electron emission, metals are used because they have many free electrons. If a piece of metal is investigated at room temperature, the random motion of free electrons is as shown like this picture. This is the surface and these are the free electrons. Okay. However, these electrons are free only to the extent that they may transfer from one atom to another within the metal, but they cannot leave the metal surface to provide electron emission. It is because the free electrons that start at the surface of metal find behind them positive nuclei pulling them back and non pulling forward. Thus, at the surface of a metal, a free electron encounters forces that prevent it to leave the metal. In other words, the metallic surface offers a barrier to free electrons and is known as surface barrier. However, if sufficient external energy is given to the free electron, its kinetic energy is increased and thus electron will cross over the surface barrier to leave the metal. This additional energy required by an electron to overcome the surface barrier of the metal is called work function of the metal. The amount of additional energy required to emit an electron from a metallic surface is known as work function of that material. Thus, if the total energy required to liberate an electron from a metal is 4 electron volt and the energy already possessed by the electron is 0.5 electron volt, then additional energy required, also may called work function, is 4.0 minus 0.5 is equal to 3.5 electron volt. The work function of pure metals varies roughly from 2 to 6 electron volt. It depends upon the nature of metal, its purity and the conditions of its surface. It may be noted that it is desirable that metal used for electron emission should have low work function so that a small amount of energy is required to cause emission of electrons. The work function is the additional energy required for the liberation of electrons. Therefore, it should have the conventional unit of energy like joules, but this unit is very large for computing electronics work. Therefore, in practice, a smaller unit called electron volt, abbreviated as EV, is used. What is electron volt? 1 electron volt is the amount of energy acquired by an electron when it is accelerated through a potential difference of 1 volt. Thus, if an electron moves from one point of 0 potential to a point of plus 10 volt, then amount of energy acquired by the electron is 10 electron volt. Since charge of an electron is equal to 1.602 into 10 inverse 19 coulomb and voltage is equal to 1 volt, now we can say 1 electron volt is equal to QV, that means 1.602 into 10 inverse 19 into 1 joule. That means 1 electron volt is equal to 1.602 into 10 inverse 19 joule.